Okay, so here's a story about a heat engine. It has 4 phases, cooling, contracting, compression. Okay. Let me be clear. Here's the rule. You probably have questions and suggestions. If your suggestion makes it more like Linux, I don't want to hear it. If your suggestion makes it more like DOS or a Commodore 64 or something totally new, I'm interested. If it makes it more like Linux, I don't want to hear it. The Commodore 64 didn't use ASCII. That was pretty bold. That was 1982. ASCII was pretty established. Think of the freedom, the openness. Do you remember when video games were being invented? The openness. We've lost that. Somehow everybody's mind has been blindered and stuff. Anyway, I want to reimagine. As a matter of fact, I want to redo ASCII. At least I've done a few changes. For example, ASCII number 5. Okay, first of all, we have new line and not carriage return. Okay, just one. There's new line but not carriage return. There's ASCII 5 is the cursor position of the editor. So if I go into one of these files and I put the cursor right here on this eye, on this eye, and I hit escape. Now if I say dump menu sprite cpp.z, okay, it's got some graphics in it. It's a mix of we don't use. It's actually not ASCII. It's first of all, it's 8-bit. Second of all, it's got some other codes. So where was it? We were looking for the I. Remember, where was the I? About I equal. Where was it? There it is. There's the I right there. Okay. So there's, you see where I'm pointing? Oh, it's underneath the, okay. There's my face I have to worry about. Okay, here's the I. Now look at this character. Oh shit. Oh, you know what it is? Wait, there's 2 5s. What? Maybe we have a bug. That's good to know. Anyway, there's 2 5s. That's the ASCII 5. How did we get a bug? We can fix it. That'll be entertaining. Where were we? We were in All Docs? No, we were in okay. Dump. Oh, well, let's go immediately. Okay. Anyway, so so look at this. We have a sprite graphic in the file. We saw it in the file. What is this? Let's look at this program. Document. Okay, we are now in form mode. In form mode, you skip over static text. We clear the text. We print a sprite, and the sprite has a tag. Then we print a menu. These are menu entries with. This is the left expression. This is if you click with the left button. This is the result you get, 100 or 200. Then this is like run This is like run dialog box or something. This runs the menu, and if it's greater than 0, God said he wants one voice for audio. That means one frequency at a time. So what does this program do? Look at that. We have an icon menu item, 50 hertz, 100 hertz, 200 hertz, 100 hertz. Cancel. Okay, so now look at this. One of the tests of quality is how many lines of code does it take to put a triangle on the screen. The better your engineer, the fewer lines of code to put a triangle on the screen, okay? It's very, very difficult to reduce the lines of code. OpenGL, X Windows, all of those are monstrosities. Not at all appropriate for a Commodore 64. Now we cherry pick. We don't want to do database servers. I have covered the. This is 100% proven technology. There's no question that it works. It does what I want it to do. I have limited. So there's about 20 games in this directory, and for example, this is a car racing game. It has graphics and source code, and this is Wenceslas. This has little men. Okay, I have a Rawhide. I like to be original. The graphics package has a zoom capability built in. At any time, you can hit Control-Alt-Z to zoom on the cursor. No GPU. This is done in code. It's graphics mode. It's not text mode. Control-Alt-Z at any time. Now, if you do Control Adobe, you can drag the window around. It's built into the graphics layer, so you always have this available. You always have pan, and you always have zoom available. Always. There's even a grid. You can do a grid with snap to. You can snap to the grid. You can change the offset in the. Okay, so those are. Now. We read whole files at once, okay? That's the way we operate. That's not appropriate for some applications, but we don't want those applications. Forget it. Red C is for contiguous files. So we don't want multimedia. This doesn't use paging, more or less. As a matter of fact, we're going to get Intel to boost the long mode is going to have an option for no paging, and you are going to optimize for it, because when everything is done right, no paging is faster. A lot faster. It's probably twice as fast. Okay, so you are going to optimize for no paging. It's not 5 times as fast, just about twice as fast. How many memory reads does it take for each access? It takes 5 if you have paging. It takes 1 if you don't have paging. And the memory accesses are what slow you down. So there are 5 times as many accesses for paging as with no paging. So that's a lot faster without paging. Anyway, so we are going to, in the end, they are going to optimize for no paging. So somebody wanted to know about my graphic file compression. Oh, first of all, Control-Shift-M is my to-do. Control-M is your personal menu. That's where you put, that's like your desktop. Control-M is your personal menu. Control-Shift-M is just a handy document for to-do list. Okay, so as a matter of fact, we want to investigate. I'm going to do Control-L, link to file. I go to file, F4 for selecting a file. We go to demo, doll docs, sprite menu, escape. I do boot drive is what I always change it to. Cursor number 5 double. Okay, I'll do that shortly. So you want to know about my graphics file format and my graphics compression. First of all, we use 16 colors, not 16-bit. We use 16 colors. Okay, if you have 20 million colors, it's not very often that one color is next to the same color. If you have a picture, if you have a 24-bit color picture of a tree, you know, one pixel is almost never the same as the pixel right next door. Okay, so if you did run length encoding with 24-bit color, it's the most silly thing. You would never do. You cannot do run length encoding with 24-bit colors of trees, photo images of trees. That's ludicrous. It's worthless. Does that mean run length encoding is bad? Well, if you have 16 colors, now it's an option. Now you might have 100 pixels of white. You might have 8 pixels of red. You might have, okay? So what they do for 24-bit is they make it lossy. That means you say, okay, well, these two leaves are almost the same color. Let's just call them the same color. That is totally inappropriate for what we have. So you do not want to do lossy compression with 16 color. And there are, first of all, we have file compression built into the file system. When you read the file, it will uncompress it if it has a Z. This is not, some people think this is modules, and some people think this is multiple files in a layer. No, this is built into the file system. Compression built into the file system. Now, you can only do compression if you read and write whole files. You can't do compression. Now you can make these uncompressed by just changing the name. When you do a move, you can't rename. You do a move. There's no rename command. Do you want to know why there's no rename command? Because you can't just change the directory. Oops. Move or rename. I call it rename. You have to. If you go to Nazi. If you go to Nazi. Okay, it's 573. Now it's 3B5. So there's a the kernel has a compress LZW compression built in. It's you know, you might say, well, we can do better. Yeah, but this is pretty low line of code count. and it's simple. We would like, this is supposed to be like a Commodore 64 where you can look at the code. I think a person can understand this. This is pretty good. So if we already have that, LZW is byte compression. That means if you have repeated bytes or you have the same pattern of bytes. So it works on graphics for 16 color. We store our color, it works. Okay, we already have it, and so that's double reason. So you know what? The whole world revolves around Temple. Okay, we make a graphics file format where Temple is the priority. That Temple is the 16 color. We make a 16 color format. Now this is the beauty of this, is that kids can read it. Well, I am a little bit disappointed that I put a compression into an option for compression. That means they have to call the compression routine. That's a little bit of a disappointment. They can, I have to double check, but I think I'm pretty sure you can operate without compressing. It'll read non-compressed. I just forgot about the. Anyway, one of the primary goals is transparency, so that a kid can make. Let's say you're building a tool for BMP files. Okay, have you ever looked at the BMP file spec? It's clusterfuck. There's no way a teenager could read all the different BMP files. Okay, and that's not good. That's ludicrous. Why can you not read a simple graphics file format? Now the BMP file put a header with the variable length to plan for the future, but as it turns out, if you make it big, it's clusterfucked. So make it so that it cannot be expanded. So you make it so that it cannot be changed. If you change it, you're going to make it so that a kid cannot do BMP file tools. Let's say the kid wants to make a tool that takes a BMP file input, does an operation, and then saves a BMP file. He has to handle all the cases. It's impossible. The file has been made too clusterfucked, so he cannot make a tool that reads a BMP file. So we want to make it so that a kid can make a graphics file. This will work if he doesn't use he cannot if he doesn't set the compression. It's easy. It's really easy. It's trivial. Anyway, so we have different goals. So is this we cherry pick? Okay. I want to handle. The concept has been fully tested. It does everything I want it to do. If you bring up something it can't do, I don't care. I don't want it. I'm almost assuredly I don't want to do it. I've done these 20 games. That's what our goal is. We want to do those well and simple. Now you can, in order to do more stuff, you have to make it more complicated, and that's not what we want. I want, when you hit F1, I want you to see the light at the end of the tunnel, and I want this to be a cozy ROM, or a cozy ROM, where you can master every single command. I want it so you can master every single command, okay? Because there's a certain satisfaction in. Now, as a matter of fact, we're gonna put one version of the ROM into the Intel chips every 7 years. God said a 7-year cycle. That's long enough. That's about as long as the Commodore 64 lasted, and people actually got to memorize the ROM. If it lasts for 7 years, there are going to be people that memorize the ROM. As a matter of fact, it is position independent, but there's no reason you don't memorize. There's no linker for fixed addresses, but as a matter of fact, you could start memorizing the addresses of things. You remember FFD2? That used to be the output character put jar. So anyway,